So apparently I forgot to add the cutout for the cross slide lock. You know, this is hardly click spring level hand filing, but it does get the job done. Well, hey and welcome back to rebuilding the lathe bit by bit until I have a completely new lathe. We left off in the previous video having scraped the new Gibbs strip flat and having fitted the new heavy duty cross slide to the lathe. And so far I think this project is turning out really well. So in this video I'd like to continue on that momentum because we have a lot of things that need to get done. The next big part of the project is to rebuild the lead screw for the cross slide. Now I know you're going to ask, well, is this step necessary? And the real answer is probably not, and I can't imagine that most people would do this step. However, the thing I do want to stress is that I do intend for this lathe to be my forever lathe, or at least the long-term lathe that I'm going to be using for at least the next 5 to 10 years. And the whole point of this project is to improve this lathe and to fix any of the small problems that have been causing me issues, and the lead screw is one of them. There's nothing inherently wrong with it, but I still find the pitch to be a little bit coarse, well at least maybe a bit coarse for a lathe of this size. You know, it's a 3mm pitch, so for every full turn of the dial, the lathe is going to take 6mm off the diameter of the part that I'm cutting. Again, there's nothing inherently wrong with that, but I do find it to be a little bit coarse for a lathe of this size. Considering that I'm coming from two lathes which both used a 1mm pitch lead screw, so effectively a third of this, I found that dialing in the tool to cut accurate or precise diameters was a lot easier with those lathes. So to make my time using this lathe a little bit better suited to me, I'm simply going to recut it with a finer pitch. Now the thread profile that I'm dealing with here is a metric trapezoidal, and that's a more efficient profile than using a more common 60-degree V-thread. The included angle here is 30 degrees, and that's a lot more efficient. I mean, in fairness, I could use square threads, I have done that in the past, but they come with their own special issues. Now I don't currently have any carbide inserts for cutting this specific thread, but I do have a lot of custom high-speed steel cutters, and I thankfully have one which I ground up a few months back. So let's go ahead and get this project started. I'll get the old cross slide back on, and then I'll face off a piece of some 1045 medium tensile rod. I'm not exactly sure what metal they used for the stock one, but I know it's a steel and it's not hardened. Now here comes the tricky bit. The full length of the part is going to be at least 45 centimeters long, and to keep it concentric and avoid any run out, I'm going to be doing all the machining in one setup. As opposed to only machining the threads and then flipping the part, or then pulling it out, and then machining the rest of it. And I'm sure you don't have to have used a lathe to know that even with a live center, the part is so long that it's going to deflect a little bit as the tool pushes on it and cuts. And I could definitely see this part chattering and probably turning a taper at the same time. The good news is that there shouldn't be a huge setback because the lathe thankfully came with a follower rest. If you've never seen one of these used before, they're essentially like a steady rest, except the steady rest will bolt to the lathe bed and it stays in place, whilst the follower rest will bolt to the carriage and move with the tool. In both cases though, they're simply there to provide extra support for the stock and stop it deflecting and hopefully stop it chattering. As you can probably see though, it has a fair amount of offset to the right hand side, so I'll have to rotate the compound over so that the cutting tool is to the right side of the follower rest. I should also point out that this is going to be my first time using this follower rest. In fact, this is actually my first time using any follower rest, so this is going to be a big learning exercise. I should also note that this is my only piece of stock that's long enough in the right material, so I guess no pressure. Good thing no one's watching. Now having read a few guides, I think the hardest part in using the rest is going to be getting the pressure right. I want to make sure that's providing enough support, but not too much that it's pushing the material into the tool or pushing it downwards. If I do that, the part will probably come out tapered and probably undersized. Oh well, wish me luck. Now because I'm using a brass bushing, I do need to run the lathe a bit slower than I normally would. But so far the surface finish looks okay and it's not producing a tapered part. However, as I kept machining, you can see that the brass was starting to wear down and break apart. And as a result, the pressure on the part started to drop and it started to chatter. This, however, wasn't unsurprising because I've dealt with this before. The steady rest also used the same brass fingers as the follow rest did, and when I first used it, it disintegrated quite quickly. And the big reason for this is that they've simply used a very soft alloy of brass when they shouldn't have. I think the correct material would have been an aluminium bronze. It's a lot harder and a much better bearing material, but of course it costs a lot more, so that's probably why they didn't do it. Either way though, on the very last pass, this did cause a bit of a problem, because I tried to correct the pressure on the fly, and I think I got it a little bit wrong. For a brief moment, I think I overcorrected and added a bit too much pressure, and unfortunately that seems to have caused a very small part of it to have a bit of run out. Thankfully though, it was only in a small section, so I was able to save the part. With the rest of the part now taken to size, I can now cut the threads, and it's very important that I cut this as a left hand, or I guess a reverse thread. Cross-slide lead screws are always a reverse thread. And once the fit is established, we can now part it off and get the other side cleaned up and an M6 hole drilled and tapped. I'll now set it up in the milling machine to get the keyway cut. Now the end mill that I'm using has a slightly chipped flute, so instead of plunging it and risking breaking the flute or breaking extra flutes, I can simply come in from the front and machine the keyway to size. I'm also going to need a hole for a roll pin. Now the reason for this is that the gear teeth is simply a set of gears machined into a collar, and that collar slides onto the screw and then it's held in place by a roll pin. Now I was considering to make the gear sort of integrated into the new lead screw and make it as one part, but this is a 1.5 module and I don't currently have a cutter for that size. So at least for the moment, there's no harm in ripping off the old one and putting it here. And thankfully it fits well and the holes line up. So that, ladies and gentlemen, is the new lead screw. Same as the old one, just a slightly different pitch, and it should give me better resolution when I'm cutting parts. Now I was considering to machine a new dial, but considering that I use the DRO for pretty much everything, I don't think I've used the old manual dial since I put the DRO onto the machine. So at least for the moment, I'm just going to leave it as is. What I do need to do though is make up a new nut to accept the new lead screw. Now the stock design uses sort of a nut with a perpendicular stud screwed into the top. Now that locates into a very tight fitting hole and another screw pushes against it to lock the stud in place. Now I don't know if this design is necessarily better than any of the other designs that I've seen, but the way that I see it is that if all I'm having to do is simply hold the nut in place, the way that I hold it probably doesn't matter a whole lot. So in effect, I am going to do a slightly different design. Plus, there's also no way that I could have tapped a hole maybe 70mm deep, so the design would have had to change anyway. So the design that I'm going to go with is very similar to what I had on the old mini lathe. Essentially 2 bolts will hold it in place, and all I really need to do is get the hole location to be spot on. I'm also going to use a piece of proper bearing bronze to make this, which should be a lot better than the brass one which came with the lathe. So the first thing I'll do with it in the mill is I'll mill the top flat and then I'll drill 2 holes for the bolts. Now because I knew when I started this project that I'd be dealing with an offset hole and I'd also be cutting a very deep Acme thread, which would require a custom cutter to be cut and would probably chatter like crazy, I decided that single point cutting it would probably be a lot more trouble than it was worth. And that's why a few months ago I went ahead and made this custom trapezoidal tandem tap. Now if you didn't manage to see that video, or if you've never seen one of these before, these taps can look a little bit crazy, considering that they're about 10 times as long as a normal tap, and also considering that it has 2 taps built into one. Now the way that this works is that the front half contains a finer, smaller profile at the same pitch as the full profile. The idea is that the bottom half will do the roughing, and then the full profile will follow it, and in theory, it should take a lot less force to cut it. Now it certainly took a fair amount of force because we are removing a fair amount of material, but it didn't snap, so I call that a win. And I think the threads came out looking really good as well. I can now get it back in the milling machine to cut a slot in at one end. This will be so I can tighten the end against the thread, and that's going to help remove the backlash. Now that seemed to work for the most part, but at the very end, the blade seemed to want to follow the thread profile, and it started to curve up a little bit. Probably a combination of a very thin slitting saw blade and the blade getting a little bit blunt. With that now done, I can now drill 2 holes and then get them tapped for a set of screws. Alright, and I think that turned out looking pretty good. Before I can call it done though, I do need to get the cross slide in the milling machine to drill and counterbore 2 holes for a set of cap head screws. and thankfully that goes together quite well. However, when I went to put it back on the lathe, it started to jam somewhere, and I couldn't for the life of me figure out exactly where or why it was jamming. Especially considering that, at least on paper, the part should fit. However, after a bit of searching, as it turns out, whilst the channel is definitely wide enough for the nut, the hole isn't exactly drilled in the perfect center line of that channel, and it also doesn't help that it tapers inwards towards the front. So as you can probably see, it's grabbed and it's rubbed off the paint on one side. So a quick trip back to the milling machine to take it down on each side, and it now slides in a lot better. And with it very quickly now put back together, we can now see that the nut and the lead screw are now working. But there are still a lot more things that still need to be done. For instance, I need a new set of T-nuts to use with the new cross slide. I have a slightly oversized piece of offcut stock, which will do the job just fine. I'll get into the mill and I'll remove most of the excess stock. I can then get it cut in half and then drill and tap them for M10. And I think they turned out looking pretty great. The tops are just slightly shy of the cross-slide surface, which is really what I'm looking for. All in all, good stuff. The final thing that I'd like to do is add some oil grooves on the bottom surface. This should help me apply a well-distributed coat of oil onto the cross-slide. Now I would have liked to have added an oil groove to the dovetail, but I don't currently have a tilt vise or a cutter that could do that, so at least for the moment, that feature may have to wait. I've purchased these 6mm button oilers off eBay. They're about 50 cents a piece, and they should do the trick. Now according to the calipers, these were spot on 6mm, and having learnt in the past that drill bits can and will cut oversized if you're not careful, and given how that these need an interference fit to work, I'll have to be very careful when I add them, because the last time I did it, I had to Loctite them in place. Now I did a quick test fit and I ran a 6mm drill through a piece of steel and the hole was just oversized. Not by much, but by just enough that it wouldn't fit snugly. Now the combination which seemed to work the best was to drill all the way through it using a 5mm drill and then follow it up and counterbore it to the desired depth using a 15th 64th drill. That's roughly 5.95mm. And in fact, it's these situations like this where I really need a hole just under or over, or in really strange sizes, where imperial drill bits work the best. The rest of the time, they're pretty good paperweights, but that's about it. With the oiler holes now figured out, I now need to figure out the oil channel design, namely what shape and what length. There's obviously a lot of information out there on designing internal oil grooves for bushings, but there's less information on how to design them for a lathe cross slide. It also doesn't help that I'd put two massive T-slots in the way, so it has designed me into a bit of a corner. Now a design which I saw that was used by several people featured grooves that were cut in a zigzag pattern, and apparently that design should help distribute oil more evenly both sideways and lengthways. And given that I'm also working around these cutouts, I think this design may work best here. Now, in deciding where and how long to place them, I eventually settled on having them run just shy the full length of the carriage dovetails. Doing it this way should prevent the oil leaking out at each end. Now, I was going to use the front two surfaces being aligned as a sort of reference point for oiling it, so when I oil it, I know that the oil channel is centered on the carriage. But because someone decided to put a lock screw in the position where the oiler was going to need to go, I pushed the oiler forward by about 40mm to use the first scrub screw as the alignment. And it probably worked out a lot better anyways, because when I use the lathe, I normally have a fair amount of the cross slide sticking out the front. So with that now settled, I'll now take it to the mill and I'll get the oiler holes cut. I'll also do one in the centre for oiling the cross slide nut. And because the mill is short by about 5mm of travel, I'll have to flip the part to do the other side. With that now done, I'll flip the part and then I'll chuck in my precision marker. I'll rotate the vise until I find an angle that looks roughly right. Probably goes without saying, but the oiler grooves don't have to be all that precise. With that now figured out, I now need to find a cutter that works. Now the last time I cut oil grooves, I used a 6mm ball cutter, and the grooves ended up being way too big. Now what I eventually settled on using was a center drill, which has a relatively small but wide tip. Now I wouldn't want to do this with one of those cheap center drills, but this one here is fairly expensive and it has really sharp cutting geometry, which will allow it to work here. I know this isn't exactly the right tool for the job, but I've used this for wide engravings quite a few times in the past, and it's always worked out really well. With the first channel now cut, I'll line up the second and then get that cut. I can now flip the part and rotate the vise and then cut the next two. And I don't know about you, but that turned out looking way better than I thought it would. There are a few small burrs which need cleaning off, but apart from that, the cutter worked really well. And the last thing to do is I'll get the oilers put in. All in all, I think the project's looking really good so far. I don't currently have a flexi nozzle to test out the oilers, and the oil bottle that I have doesn't really work here, so that's one area that I'll have to test in the next video. Now this project still isn't done. I still need to make the solid compound and the new tool post, which I'll hopefully get finished soon. Till then, thank you very much for watching, hope you enjoyed this video, see you next time.